Okay, this is a grade 9 review of 14 questions, most of which come from various chapters in the book. I think I covered most of the chapters we've done so far. So as we go through this, if you're watching this in June and you're preparing for the final exam and you're just giving yourself these questions again, I'm sure you didn't remember them from May when we did them. So you can fast forward to a question you want to do, or you can just do all of them one at a time and listen to the explanation, make sure you're doing them properly. The first question gives you a picture of me, and it says this is drawn at a scale of 2.5 to 30. How tall is Mr. Mac? So the first thing you have to remember in this question is that scale is diagram to actual, or D to A. And your scale factor, if you think about back to that, is the diagram divided by the actual. So what I'm going to do for this one is I'm going to use not the scale factor because I don't know how tall I was at first. I'm going to use scale and use proportional reasoning to solve it. So I'm going to say that scale is diagram over actual. And since this represents the diagram and this represents the actual, I'm going to put 2.5 for D, and the actual me is 30. For every 2.5 in the drawing, centimeters, millimeters, units, whatever, the actual me is 30 of those units. So since the drawing of me, or the diagram of me, is 15.6 units, how tall is actual me will be X. Now there is various ways you can do this. You can figure out what did you multiply 2.5 by to get 15.6. That's one way to do it. A simpler way is to simply use cross multiplication. So 2.5x will equal the product of 30 and 15.6. Bring my calculator over. 15.6 multiplied by 30 is 468. And if I want to isolate the variable here, I'm going to divide both sides by 2.5 to find out what x is. So divide that 468 by 2.5. And it's going to tell me that x equals 187.2. Now we're not done yet, because you have solved for x, but you haven't really defined what your answer is. And since this x here is representing the actual me, you must therefore put a symbol there for Mr. Mac is 187.2 centimeters tall, which is actually a true statement. I am 187.2 centimeters tall. The second question gives you two triangles and says triangle ABC is similar to, that's the little symbol here, the half of a is approximately to, the half, squiggly, I mean similar to. So triangle ABC is similar to triangle DEF. And what that means is when two triangles are similar, there are some truths that are, the truths mean that corresponding angles will be of equal measure, which is not important for this one, but sometimes it is important. And more importantly is that corresponding sides will be proportional or increased or decreased by the same scale factor. So again, we could figure out what the scale factor used to draw this smaller reduction. So the first thing I'm going to do is say this was my actual triangle that I started with, and this is my diagram. And the reason why I chose A for that one and D for the other is because if you know both sides of a shape, you should always make that your starting point. So I know everything about my actual, and the drawing, I don't know this one, so I'm going to keep that my D. And that's the first thing we usually talk about, is defining which one you want to make your D and which one you want to make your A, since it's arbitrary. So this is A and this is D. If we figure out the scale factor, I want to know what did I multiply this by to get 1.7. So again, scale factor is going to be D divided by A, or in this case, 1.7 divided by 6.8, right? And that will tell me the scale factor that I multiplied 6.8 by to get 1.7. So if we take this and go 1.7 divided by 6.8, it's going to tell me decimal 25. And what does this mean? Well, this means if those two triangles are similar, like they said, then each of the sides would be multiplied by 0.25 to get this reduction of the diagram D, right? Because 6.8 times decimal 25, if I just double check that, 6.8 multiplied decimal 25 does equal 1.7. So therefore, if I swing it over here, 12.4 multiplied by decimal 25 equals 3.1. So therefore, x is 3.1 units. That is one way we can do it. That's called calculating the scale factor. What was used from my original triangle to create that reduction? What was the scale factor? What number did I multiply all of the sides by to get the reduction? A second method would be to set it up as a proportion. So again, just like we did with the last question with me, d over a is scale. And if I choose, this is my d, so 1.7. So 1.7 is my d over the corresponding side of 6.8. So diagram to actual will be proportional to x over 12.4. Okay, so rather than figure out the scale factor, I'm just going to set it up as a proportion. Here we would multiply across this way to get 6.8x. Here we'd multiply across here to get 12.4 multiplied by 1.7, which is 21.8. And finally, we take that 21.8, isolate the variable by dividing by the coefficient, and we get 3.1. So x equals 3.1, which is the same answer I got using scale factor. Question 3 says, put these numbers in ascending order. So it does not say you can't use a calculator, so I can use a calculator if need be. So the square root of 9/64 is the same thing as the square root of whatever 9/64 is as a decimal. So 9 divided by 64. Did I do that right? 9 divided by 64. I did. Is the square root of, oh heavens, that's a lot of stuff. 140625. Square 0, 140625, correct? Okay, so those are the same thing. And if I take my calculator and then say, what is the square root of that? It's going to tell me the square root of that is 0.375. So this first number, when I change it to a decimal, and that's what we're change them all to decimals, is this 0.3 repeating. I'm going to keep 3 decimals there just to have it, to keep it in reasonable comparison, is that. The square root of 1, any number times itself is 1, so it's 1. 2 over 5, if I change that to a decimal, I know negative 2 divided by negative, oh, wrong button. Negative 2 divided by negative 5 is, or 2 divided by 5 is decimal 4. So since it's a negative divided by negative, it's going to be a positive 0.4. And the last fraction, 26 over 83, 26 divided by 83 will equal 0.313. So the first thing I did is I created all of them as decimals. And then if I put them in ascending order, that means I want to start at my smallest number and build it back up. So my smallest number here is this one. So the first one I'm going to put down is, this is my smallest. My next smallest would be this one, which is 0.3 repeating. Then this one, which is 0.3, sorry, the square roots of 9/64. Then this one, which is negative 2 over negative 5. And finally this one, which is the square root of 1. So the solution to the question, put them in ascending order. Those would be all of the rational numbers or irrational numbers. No, they're all, no, I guess one's repeating, but that's still a rational number. So these are all rational numbers in ascending order. The next question is simple, a simple fraction question. What's 1 2/5 take away 2 3/4? Now, of course, in grade 8, you would never have it where the first fraction is less than the second because you're going to deal with a negative. So in grade 9, the extension was to be able to give it that way. So I'm going to change both of these mixed fractions to improper. So 7/5 take away 11/4 is the exact same question as the mixed subtraction above it. In grade 7, you learn to find common denominators, which would be 35/20 take away 55/20. Keep your denominator, subtract your numerators. Oh, sorry, 55. Keep flip change. 35 positives and 55 negatives is 20 negatives. So when you do that, did I do something wrong? Where are we at? Oh, yes. Thank you. 28. Thought there was something wrong there. So 28 plus negative 55. What does that work out to be? 27? Negative 27? Which is negative 1 and 7/20 as a final answer. Without a calculator, determine the square root of 0.09. So what we said was when you have decimal numbers and you're calculating the square root, and you have to do it without a calculator, the easiest way to do that is to reinterpret it as the square root as its fraction form. And that seems counterintuitive because normally we change fractions to decimals to make them easier. But when dealing with square roots, these two questions are the same thing. What is the square root of 9/100ths? What's the square root of 9/100ths? And we know the square root means what number when multiplied by itself is a given number. So what fraction multiplied by itself is 9/100ths is the way we're going to find the solution for this. So what number multiplied by itself is 9? The numerator will be 3. And what number when multiplied by itself is 100? The denominator will be 10. So therefore the answer to this would be 3/10. And therefore the answer to this would also be 3/10, or decimal 3. Common mistake on a multiple choice test with the province would be 0.03 is a multiple choice answer. And of course, it looks like it should be 0.03, but in fact, it's actually 3/10, not 3/100ths. Your next question is your exponent chapter, and it says, what is negative 10 squared without brackets plus negative 2 in brackets cubed? So remember, the key to this one is knowing that this is not the same as this. This is negative 10 as a base squared, which means you will multiply the base negative 10 by itself twice, or negative 10 multiplied by negative 10, which is positive 100. This one, and we talked about it being multiple things, but I like to think of it as being the opposite of 10 squared. And since 10 squared is really 100, then the opposite of that would be negative 100. All right. So the first part here is to know that negative 10 squared is not positive 100, but rather negative 100. Plus negative 2 cubed is negative 2 multiplied by negative 2 multiplied by negative 2, which is positive 4, multiplied by negative 2, which is negative 8. So negative 2 cubed is negative 8. And therefore your answer, the sum of a negative 100 plus another negative 8. There are no zero pairs when you add those, and you have simply 108 negatives. In your next question, you are dealing with the addition/subtraction of polynomials. In this case, the subtraction of polynomials. If I was to draw this, so if I was to draw it, this is what the picture would look like. 4x and negative x squared and positive 7. Take away negative 2x squared plus x minus 1. So since subtraction of polynomials, we said, was the same thing as subtraction of integers, the rules for subtraction of anything apply. In this case, I'm going to change my subtraction to addition. And in the second trinomial, I'm going to change everything to its opposite. So those are going to become positive x squareds. This positive x is going to become a negative x. I suppose I can just erase it. That would be easier. You didn't have to. I'm just explaining it, and then we'll talk about it. Negative x, and this will become a positive 1. So obviously, once we have this drawn, if I was combining like terms, this one right here and one of these ones would make a zero pair, and I'd be left with 3 x's. One of these negative x squareds and one of these positive x squareds would make a zero pair, and I'd be left with 1x squared. And 7 of these positives and one more of these positives would make 8. Now, from a picture perspective, what I could also do is then rearrange them in descending degree of terms, which means I would probably then say that's my highest degree term. That's my second highest degree term. That's my third highest degree term. So I would just put them in final order of being x squared plus 3x plus 8 if I was just dealing with the picture. However, of course, once we learned that, we said, you know what, that's a silly way to do this question. Let's make this easier. So instead of having to draw it out and think about algebra tiles and all that, we simply said, change it to addition and use the opposite of each, and then simply gather like terms. Starting with my highest term, which was x squareds, 2x squared and a negative x squared make an x squared. Put lines through it, you're done. A negative x and a 4x make positive 3x. Those two are done. And then a positive 7 and a positive 1 make it positive 8, and I get the same answer as if I had drawn it, but both ways help you understand why this method works. In the next question, we're actually dealing with division of a trinomial by a monomial. And what we learned was that distributive property, so if I was to multiply them, giving you a different question, if this was the question, a monomial multiplied by a trinomial, you would have to use distributive property, and each of the terms in the trinomial would be multiplied by -2. In this particular question, though, we're not dealing with multiplication, but rather division. But every term in the trinomial has to be divided by -2. So if I want to think of them as separate parts, the 10x squared is going to be divided by -2. The -6x is going to be divided by -2. And the -8 is going to be divided by -2. So if I think about each of those terms being divided by -2, I could simplify each. 10x squared divided by -2 will be -5x squareds. -6x divided by -2 will be a positive 3x. And -8 divided by -2 is a positive 4. So when I divide the trinomial 10x squared minus 6x minus 8 by -2, I end up with this trinomial as a simplification. The next question is actually an algebra question, comes from chapter 8. And it says 2x minus 5 has the same value as or is equal to -10x's plus 7. So again, in grade 7, we would have had something that looks like this. In grade 8, we would have had something that looks like this. And in grade 9, we added the idea that variables can exist on both sides of an equation. And when they start that way, you were told the easiest thing to do was get rid of it on one side of the equation first. Don't worry about your constants first. Get rid of x on one side of your equation. And typically, you want to get rid of it on the side. So the easiest thing to do is remove it on the side that has the least amount. In this case, -10x is the least amount. So I'm going to add 10x to both sides, which is adding a monomial to a binomial, etc. Here, this is going to make a 0 pair. And on the right-hand side of my equation, I'm going to be left with just a 7. Over here, I'm going to have 12x minus 5. Because these two terms are like terms, and I can combine them to make 12x. Now I have a two-step equation that I would have seen in grade 7. I'll add 5 to both sides to get rid of the constant. I get 12x equals 12. Divide both sides by the coefficient, and x will equal 1. So the solution to the question of 2x minus 5 is equal to -10x plus 7, x is 1. And again, if you wanted to make sure that was correct, take your 1 and substitute it into the equation where x was. This is 2 take away 5, which is -3. This is -10 plus 7, which is -3. And when x equals 1, both of those sides are equal. Both of those sides have a value of -3. The next question, we have an algebra question that is variables only on one side, thank heavens, but we have fractions. And we were told that you can do it a couple different ways. The first way, of course, is to subtract 1/6 from both sides to get rid of the constant. But the problem is, when you subtract a 6th from this side, it requires you to actually use fractions, find common denominators, etc., etc. It's not the best course of action. The easier way to deal with fractions when they're in equations is to take both sides and multiply them by a common multiple of the denominator. So what multiple does 3, 6, and 12 share? It does share the number 12. So if I multiply both sides by 12, this side will become 11. And each of these terms in the binomial have to be multiplied by 12. I'll write them separately. 12 over 1 multiplied by 5x plus 2 over 3. And 12 over 1 multiplied by 1/6. When we did this, we talked about the fact that it's kind of important that you cross-reduce. You don't have to, but if you cross-reduce, it makes the simplification of the terms much easier. So when I'm multiplying, that 12 and that 3 are going to multiply out, or cross-reduce out to become 4, which means the denominator is now just 1, which doesn't exist. So if I multiply 4 by 5x plus 2, I have to use distributive property to give me 20x plus 8, right? Because I have to use distributive property here. And the second term, that 1/6, if I cross-reduce that, I get 2 over 1, which if I multiply that out, it's going to be a plus 2. So when I do all that jazz, I end up with this complicated-looking thing, which is the same thing as this thing here, which is still a grade 7 question, but it's a little bit more complicated. Subtract 10 from both sides. I get 20x equals 1. Divide both sides by 20. And x will equal 1/20th or 0.05. And that's the solution for that question. Your next question is actually a linear relations question. Comes from when we graphed linear relations. It's an extension of grade 7 and grade 8 and grade 9. They're all the same thing. This question happens to have a pattern that starts with the first number is 10, then 7.5, 5, 2.5, and 0, and says, what's the 100th number in the pattern? So from experience, the first thing you have to make is a table of values. And some of you might have put x and y here. Now, you can put x and y if you want, but in grade 9, we learned that it's sometimes more useful to actually define the variables by what they represent. So we're going to put the number in the sequence and its value. So the first number has a value of 10. The second number has a value of 7.5. The third number is 5, and so on and so forth. And we're looking for the 100th number in the sequence because we want to know what its value is, or what is that number. So we learned that the relationship between n and v will be linear in this particular one, as long as the distances or the spaces between values are consistent. In this case, it's going down by negative 2.5 here, and it's going up by 1 here. Our coefficient will be negative 2.5 divided by 1, or negative 2.5. Once we've found our value of our coefficient, the next part was to be to find our constant. We do so by taking any ordered pair, usually the first one, substitute it for n, and substitute it for v. When I simplify this, I realize that both sides aren't equal, but a constant of adding 12.5 is necessary to balance the two sides, which means the equation that represents all of the relationships between the number and its value fall under the equation negative 2.5n plus 12.5 will equal the value of the number. So with that known, you take your equation, substitute n for the 100th number to find its value, simplify, and you get negative 237.5 equals v. 7.5. 237.5 is the value of the 100th number. Anyone get that? Did I make a mistake? I could have made a mistake. Did I make a mistake? Other people got it? Good. Sometimes I make mistakes. The next question is a part of our chapter 10, I think, on linear inequalities. And this is an example of an inequality. Now what we learned to do was solve it, isolate the variable like we would in equalities. I'm going to subtract 1 from both sides to give me negative 10x is greater than or equal to negative 10. Isolate the variable by dividing both sides by -10. And remember, in inequalities, when you multiply or divide both sides by a negative value, the only thing you had to remember was you had to flip your inequality sign to make the final statement of x, all values less than or equal to 1 will be true. So here I'm going to put 0, 1, and 2. Since it's including 1, because it's all values less than or equal to 1, it's a closed boundary point. All values less than or equal to 1 means my arrow is going to go this way, and it will encompass any values that is equal to or less than 1. The last two questions are from everybody's favorite unit on circle geometry. You have a circle here with no numbers given, but it appears to have what's called a perpendicular bisector, meaning it takes the chord AB and cuts it into two equal halves because the radius is cutting it perpendicularly, which means I know from my knowledge of perpendicular bisectors that it cuts a chord in half, so I'm going to put those two little red lines on it to remind me of that. AB is 24 centimeters. CD is 9 centimeters. This is 9 centimeters. Since the whole chord was 24 and they're equal length, each of these will be 12 and 12. What is the circumference of the circle? Well, I don't know very much information here. But from experience, since this is perpendicular, I can make a right triangle. And that red line that I drew was a radius. Redraw my triangle over here with 9 and 12 and x. Solve it with Pythagoras. 81, 144, 225. Since the area of the square attached to that hypotenuse is 225, the length of x will be the square root of that, which is 15. So therefore, the radius of this circle is 15. But wait, we're not done. In order to find the circumference, I need to know the diameter, not the radius. But if I double it, that 15 centimeter radius is now a 30 centimeter diameter, and therefore I know that the circumference will be equal to pi multiplied by the diameter, or 3.14, or if you use 3, that's fine. 3.14 multiplied by 30. And therefore, the circumference of the circle, or the distance around the circle, is 94.2 centimeters. Last question, Destiny. Last question, of course, again from circle geometry, deals with lines of tangency. It says AB is tangent to the circle at point D and is 16 centimeters long. EF is the diameter. Did I spell diameter wrong? Why does that look wrong? Does it look wrong, doesn't it? Is it just me, or is it late in the day? And it's 10 meters long. So if the diameter is 10 meters long, what that tells me is this red line is a radius. And the first thing I know is it's 5. Since the line is tangent, I can put a right triangle there. I can put it on both sides because they're both right triangles. If AD is 4 centimeters long, I'm going to put this over here again. This is 5. If AD is 4, and the whole line AB, did I say, and the whole line is 16, that whole line is 16, that means that DB is 12. If AD is 4 and AB is 16, then DB must be 12. What I have here, when I connect my dots, AC is a right triangle, and the line CB is the hypotenuse of another right triangle. So if I draw those separately, this being 5 and this being 4, this is 25, this is 16, this is 41. Therefore, AC will be the square root of 41, or approximately 6.3, 6.4, 6.4. 6.5, I don't know. Anyone going to help me out, or am I just going to die here? Square root of 41, 6.4. Thanks for your help. 6.4 is the distance of AC because of Pythagoras. And finally, CB, the hypotenuse of a different right triangle, which this is 5 and this is 12, is going to be 25 and 144 and 169. square root of 169 is 13, and therefore CB is 13 units exactly.